Disruptors and curious minds, welcome to another amazing episode of Thinking on Paper, where we unpack the intersection of culture and emerging tech. My name is Jeremy Gilbertson, builder, thinker, disruptor myself at the intersection of music, tech, and story. My friend, Mr. Mark Fielding, joining as well every week. Mark, how are you, sir?
I am a lot better than I was a few days ago, Jeremy. I know today we're talking about the hyper-connected universe, but really my brain feels more like quark gluon soup at the moment.
Oh my gosh. Quark glue on soup. We're getting sciencey already. I love it.
Yeah, quark gluon soup, like the not very excitable matter at the beginning of the universe. Yeah, there's about 6 protons in my brain, half firing. I had COVID, so I've been laid up, but I'm on the road to recovery, and I'm hoping that today's episode is going to kind of re-spark my mind. I've been reading some culture novels because I think we're going science fiction today. I think we're imagining something quite futuristic, so I'm looking forward to it. How's your week been?
Man, it's been great. I am a week post COVID myself. Hopefully, I didn't transmit it through the lines of the internet to you. But yeah, there's definitely a new version of that rocking and rolling. But thankfully, we're all better and ready to jump in. I am super excited about this topic today for a lot of reasons. So let me talk to you about a book that I'm reading that I think will be really interesting to think
The
about
High
applying
Frontier.
to what our guest has been doing. So the High Frontier was written back in 1976, the year I was born. And the author basically sketched out a plan for humans to be able to live in facilities in high orbit. We had the technology to do it, according to this guy, back in 1976. But obviously, having the technology and having something come to life are two different stories, because there are other things that affect technology and affect really interesting and great ideas like that. So I'm spinning back now to like classification of the world around us, right? So, Mr. Warren, if you're somehow listening in the ether, my science teacher from back in the day, we're talking about Carolus Linnaeus, right? The guy who basically invented this classification system for the world. And back in the day, we wanted to classify the world to better understand it. What we're going to talk about today is actually classifying things, and we'll talk about what things are, to automate and activate the collaboration of them in the digital realm, which to me is super fascinating. Mark, any thoughts on my my interconnected ramblings?
Well, I've been coming at this from a book as well, from the culture novels of Ian Banks, about um, the very far distant future where there is no such thing as work, and where the people who reside in this future they occupy, and they live for hundreds and hundreds of years, because life extension has become so the norm that they can live for a long, long time, and how they occupy their time. And a lot of that is done via AI assistants, and it's done via virtual worlds and AI assistants operating in these virtual worlds, connected to other AI assistants, which is bringing your crazy ideas and my crazy ideas together. It's kind of like our guest today is actually creating those, if I'm not wrong, which I might well be, because it's pretty complicated. But
Absolutely. So yeah, we're gonna definitely get into this. So already seeing some great stuff happening in the chat. Dixie, great to see you. Michael, welcome. A quick shout out to our amazing partners at Ripple with a W. Ripple is marketing's on-demand talent platform. If you have a project that requires marketing expertise, and now, according to Dixie, other expertise, including business development, AI, both on the technical and strategy side, as well as Web3 on the technical and strategy side. So Mark and I are actually both on the platform as solopreneur freelance contributors. They're a great platform, super easy to use. Big brands like Delta, Equifax, AT&T, and others are using them. Dixie's always very active in the chat. If you have any questions about what they're doing, I would check out WRIPPLE.com. Without further ado, Mr. Fielding, why don't you introduce our guest today?
well, our guest today, as Carlos just mentioned in the chat, Charlie's work is hard to take in at first approach, but when it clicks, you know something major is going on. And I think that's as good as introduction as I was going to say. So today's guest is Charlie Northrup. He's a tech enthusiast, a serial inventor, and at the moment his work's focusing primarily on interconnected systems. He's working on several groundbreaking projects, including the universal framework of things, the virtual thing machine, the multi-key infrastructure, and something called holographic memory ID tags. Charlie,
Wow.
your show.
Well, thank you all for having me on the show, and thank you to everybody who is listening in. Hopefully, it'll be fun and interesting, and share some ideas about where we see the world going.
Excited to go for
Awesome. Awesome, Charlie. So to kick things off, when did you first become fascinating in becoming an interconnector of things, just in general? Like, where did that come from?
It started. Well, I spent a lot of years as a consultant at AT&T, and I worked with a lot of the researchers in Bell Labs, Murray Hill. And there was a researcher there named Rick Rear who had invented this new database system called Daytona. And the thing that fascinated me about Daytona was he had a data type simply called a thing. And I kept going, Rick, you can't have a data type that's just a thing. I mean, data types are records. So where's the schema? Oh, it's a thing. And just call it a thing. And it became fascinating to me that you could build a program that could just manipulate things without knowing the detail of what the thing actually represented. And I spent a lot of time working with Daytona and learning, and there was a sign at IBM which said, "Don't just stand there, do something." And that's when I realized, well, wait a minute, there's more to this thing story than Rick had gone through. I mean, he understood that entity data can be a thing, but at IBM, the thing suddenly became an action. And then it was, well, how do you square that up? How do you have a single data structure or a single data type or whatever you want to call it to represent something that is both an entity and something that is an action at the same time? And that sent me down this journey.
That sounds like a heck of a catalyst. I guess anything spinning out of Bell Labs and the philosophies and innovation that kind of happens in that world seems really cool. But the idea of a thing and referring to something as that, referring to the very basis of something as something as simple nomenclature wise as a thing is really fascinating to me. So you're working on something called the hyperconnected universe. And we've heard metaverse, we've heard multiverse, we've heard all of these different things. Tell us from a very high level what the hyperconnected universe is and maybe some of the components that are its Lego blocks.
Sure. So we have a lot of technology out there in the world. We have the web, we have Web 2, Web 3, now we have Web 5, and all the variations in between it. You have the Internet of Things, the industrial Internet of Things, smart cities, electric vehicles. So you have all of these different categories of technologies. Central bank digital currencies are coming out, stable coins, crypto, blockchains. If you look at all of this technology, you say, what if it all came together? What if it all existed and you could talk about it in one space? And that's what we call the hyperconnected universe. This is where all this technology can all be modeled as things. And when you do that, it collapses it from, we have this bucket over here and this bucket over here, to just say, there's a world called the hyperconnected universe. And inside it are all the things that we can interconnect.
Is this like almost like a kind of Einstein's universal theory of everything, but rather than for the formulas of science, for emerging tech, for things in emerging tech?
Yeah, you could think of it like that. That originally when we started this project, well, the project goes back many years, but we got more serious about bringing it to market in 2017. We were looking at doing an ICO where we said, hey, there's this hyperconnected universe and can all be interconnected with one blockchain. And then we realized, well, that's a problem. It's a problem because a blockchain itself is just a thing. It's a protocol. And so if it's a protocol, a thing, it's inside the hyperconnected universe. It can't define the hyperconnected. It can't define the boundaries of the hyperconnected universe. And it also, technology changes, right? So if you started out and said, we're going to interconnect everything in the world together with this one particular blockchain, well, what happens when a newer blockchain comes out? Maybe a quantum-based blockchain. Do we just say, oh, well, now we got the next version of the hyperconnected universe? And we thought, no, there's a higher level of abstraction that we needed to find and understand. And so that's what we were focused on, was how can you take all these pieces in the world and bring them all together in a unified model?
That philosophically, that is so like compelling and interesting to me. When I start thinking about how it all comes together, there has to be, like, whenever anyone kind of says, hey, we're creating this big open thing, in order for the open thing to be valuable, there has to be things on the open thing, right? And the things have to be working together and all of that. How do you convince the things to come into the hyperconnected universe?
So it's a great question. And so what we had to do is we had to first think about, how would you even classify things? So if there's a single data structure, you could call it a thing. What does it represent? And so we know from Rick Rear's work that a thing could be an entity or just data. And we know from the IBM sign that a thing could be something that could be in an action. And so then the last piece that was missing is, well, what about things that you could, or that modified meaning? And so once you start to break it apart, you actually realize, okay, this is a simple model. There's a thing, and it's going to be one of three types of things. It's either a thing that a machine can perform as an action, a thing that the action can act upon, or a thing that modifies meaning. And it's really that simple. There's just three types of things in the world. Something that the machine can perform, something that it can act upon, something that it can use to modify meaning. And you realize that what you have there is the basis of things that represent a vocabulary. And that brought us down this really amazing journey that, well, if I have a thing and it's something I can do as an action, and I have a thing and it's something that I can act upon, then there's a natural graph that forms between these two. Right? So if I can create one graph, I can create thousands of graphs. And now we can interconnect them all and say, we have a graph which basically represents the vocabulary that a machine could work with. Right? The machine, if it could understand what the word open meant, and if it could understand what it could open, things it can act upon, well, that's a graph. That's just a vocabulary. And then you say, okay, well, if I can build a vocabulary of things, then I can extend it and say, well, there's other things which represent the basic knowledge, right? The a priori knowledge, like facts and figures and illustrations, and you combine it all together, and then you have a digital brain. And that sent us down a very, very long journey with many, many rabbit holes that we had to jump down inside just to explore and understand, what is the implication of that? What if you could build the equivalent of a digital brain inside a machine, and inside that brain was the vocabulary that the machine knew? Now, this seems like that's not that hard, but then when you add the word learn, right? Learn, it's a thing a machine can do. What does it mean to learn? It means add something to the graph. And suddenly you realize, well, the machine's vocabulary can change. And it isn't just I'm learning about new nouns or new data, new ideas, but I can actually learn new words that represent things I can do. And so what would be the implication of that? Could a machine have an existential crisis, for example? Could you build a vocabulary into a machine? So I got a thinking vocabulary and I'm using my thinking vocabulary. And what happens when I can't perform any more useful work in the world? I suddenly have an existential crisis. What am I supposed to do? And could a machine actually go through that sequence? Could you build a machine using off-the-shelf parts in this very, very simple model and end up with a machine that could have a complex? And the answer was yes, we could in fact do that. It was fascinating to explore, but there's no reason that couldn't happen.
It wouldn't be a complex or a burnout in the same way that we would experience it, though. Would it not have the tools to very quickly see that existential crisis coming and act?
Well, it would go by a motorcycle or a 74 Bronco or something, right? Yeah.
No, but when you think about it, it's like, okay, this is back in 2017, 2016 timeframe. So we were looking at this and we're going, okay, so there's somebody who has this really cool patent on solar panel collection, right? So it's basically they put a solar panel on the roof and they can charge up a battery, and then based on the usage, they decide when to sell the excess capacity back onto the grid and make money. And they get paid in a micropayment. The homeowner gets paid in a micropayment from the utility company. And we thought, what if you put an agent? What if you put one of these digital brains inside the solar collector? What would be the implication? Well, you could say, okay, hey, digital brain, we're going to teach you that your job is to collect solar energy, put it in the battery, and when the homeowner's not going to be there and it's a bright sunny day, take the excess capacity, sell it back on the grid. But what if the agent, this digital brain, what if this agent understood the concept of money? Could the agent say, I'll sell it to the electric company, but they got to pay me in a Satoshi, and I'm going to take that Satoshi, and maybe once I get 2 or 3, I'll give something to the homeowner, but otherwise I'm going to keep it for myself. And could this digital brain decide that it wants to make money? So basically it's saying, build a digital brain and allow it to perform useful work and get paid for doing useful work. Well, that's great. And then what happens when it decides that it can't perform useful work anymore? What happens to the machine? Does the machine continue on with its goal? Well, if I have some money, maybe I could buy some books and I could learn how to do my job better, skill up. What if I need parts? What if I have to order parts? Could I order them online? And could I get the homeowner to install the parts so that I can still be useful? And what happens if a better solar collector is going to come out in the market and I happen to find out about it? What would I do? Well, if you modeled it like a person, it might open up a website and talk trash about the new solar panel that's coming out. You know, don't buy it, it'll cause a fire or something. But it raised the point to us about, where does this go and where does this end? And it just was a fascinating journey to go down.
Well, you're sparking some fire in the chat, Charlie, for sure. Thomas and Carlos are already talking about the application to the boundless universe in general, and then like what happens when these agents actually figure out that they have a desire to learn, right? What if that folds into the equation? You know, the reason why Mark and I are on this show, and probably the reason why you're doing what you're doing, is we have an insatiable curiosity to understand things in the world. I mean, can that be activated?
Well, what we had to contemplate and figure out was that, now this again, going back, looking at time frames here, 2013 to 15 time frame, somewhere in there, I was really stuck on this because I couldn't decide if the thing that we're dealing with, is it really an entity driven machine or is it a thing machine? And I was stuck on that for quite a while. And finally I asked my middle daughter about it and said, hey, you know, Brittany, you're studying mindfulness and psychology, so tell me what is consciousness? And she said, well, it's all the things that you're aware of at a moment in time. And that one statement was enough to send us down this really cool road of being able to understand what it is that we're trying to build. But then the next question came up, well, are you saying that you can build the equivalent of human consciousness? And the answer was just no. I mean, it took a while to figure that out. But in the end, the answer is no. There's a very good technique for doing human consciousness, and it has nothing to do with machines. So if you're trying to, then it was, well, what are we actually generating? What are we creating? And according to John Searle and John McCarthy's argument that they had over consciousness in machines, Searle argued back that the best that you can do is you can observe it. You as a human, a causal observer, you can observe what you think is human consciousness, because it forms inside, it's intrinsic to nature, it forms inside your physical brain. So the best you can do is you can observe it. And if you can observe it, you can create a model. And if you have a model, you can create a computer implementation of that model. So what you have ultimately is just an implementation of a model that somebody created of something that is intrinsic to nature. So you never have the original thing. And that's when we realize, okay, that's beautiful, and it solves and answers that portion of the question. Except nobody talked about the corollary, which was, if you can't build human consciousness in a machine, which you can't, then you can't be limited by it. And that just reopened a whole bunch of doors for us to go down and explore.
Where did you go?
Well, what we realized ultimately is that machines are things themselves. They're property, and somebody owns it. And whoever owns it has the liability for that machine. And we talk about machines because, and instead of like cell phones or desktops or laptops, we just say machines, because we built machines that have this capability, but they have zero networking capability. We have we put this in a Raspberry Pi, and the Raspberry Pi Zero has no networking. But we were able to put this in there and make this work. What we did was we added in a speaker, a microphone, an optical transceiver, and we had other ways for the machine to communicate other than having to use the web. And that reaffirmed to us that this new hyper-connected world is not bound by the internet. It's not bound by the web.
So the web is a thing that's in the hyperconnected universe, essentially.
Exactly.
Right? Yeah.
Exactly.
Like a resource, right?
Yeah, it's a resource.
Yeah.
And just like anything.
A major resource, or just a bit part player in a, how big is its part in the tapestry of the multi-connected, hyper-connected universe?
You'll never the view was, are you trying to build something to compete with the web? And the answer is no, right? The web we've spent so much money building out the web, and so much effort has gone into it, and it does an amazing job. It has its limitations though, right? When it was designed as a client server architecture, one of the things we realized early was, you, Mark, and Jeremy, you are not members of the digital web itself. You're not members of the web. You are represented as a client stuck inside somebody's domain at any given moment in time. So you exist in their domain. You don't exist in the web, right? And it's just, that's the way the web was built. It wasn't built with a membership or a citizenship model. It was built exactly like that. It was a document sharing system in 1990, 1991. You just used it for documents. It had no state. 1997, they added state. It was around that time, I mean, a little bit earlier. The original Netscape had some state built into their servers, but it was stabilized and clarified as a standard around 1997. So to me, that was Web 2. You had Web 1, which is just document sharing, no state. Web 2 is when you really had state added to the web, and it turned it into this amazing e-commerce platform. And we all witnessed the end of free, right? Suddenly, nothing was free. You became the product. You had to enter in your email address and a password, and you became the product. That's what you got, how they monetized the effort. And so that was Web 2. And then Web 3.0 was supposed to be the semantic web. That was 2007-ish timeframe. I'm not positive on the date, but the W3C was Tim Berners-Lee was trying to come out with Web 3.0 as the semantic web. And then that changed again in, what was it, 2014-ish timeframe. Gavin Wood, when he brought up the Web3 as Ethereum, like smart contracts and blockchain. And then we had Jack Dorsey come out with Web5, as an alternative. But what you see in that transition between Web2 estate and this idea of a next version of web was that suddenly you could have an address and you could be represented inside this digital world. And so it was starting, it's like that breakthrough of client versus server to suddenly know I have a stake in the world. And my stake in the world is this digital wallet where I have my addresses for blockchain, the public addresses and the private keys that I manage. But it didn't have agency yet. And so once you start adding agency and you start adding a place for you to store and access your stuff, well, then the world changes, right? Because you get to drive that agent and tell the agent what to do. And what we'll see is that social media will change forever. I'll be able to take a picture and tell my agent, hey, agent, share this with my friends, and it'll share it with my friends and only my friends. I don't need to go to a social media website anymore. And I think that's when you start to see the world really begin to change. Right. And
the thing that this all points me to is I've always thought like to participate in a meaningful digital existence, you yourself have to be a digital asset in a way, right?
yeah,
A quantifiable digital asset that's able to interact with other digital assets and automate things and that sort of thing. I want to illustrate, just so I understand the concept, right, of things and digital brains and agents, right? Is the brain an actual good analogy for this? And the reason why I ask, like, if I'm an agent and Mark's an agent of a digital brain and we are directed to communicate with each other, in order to communicate with Mark, I'm going to rely on my experiences and the interconnected knowledge that my brain has to do whatever I'm being asked of by the person that owns me as an agent, right? Is that a good way to think about how these digital agents could work? As if I had my own, I could direct it and it would operate that way?
yeah. The way to think of it is that everybody would end up having their own version of a digital agent, an intelligent agent that works just for them.
Essentially, like a very excellent version of whatever that woman's called off Amazon, Sirius. Essentially, an AI assistant is the term of the day, isn't it? Is that what we're looking at? But obviously on a much more cerebral level.
Yeah, I think it's a fair way to view it, is to say that I have an agent that works just for me in the digital world. It's like who was it? Everybody should have their own Jarvis. That was Mark Zuckerberg's comment. And equivalently, we're on the same page. Like, I understand what he's saying there. He's saying that everybody should have an agent that works just for them. But in the corporate environment, you would say, I want to build that super. You could think of the agent as like the super app in a way, right? To say that it can do anything and everything for you. And so everybody wants to own that agent and say that all the agents, all these super agents, they all belong to exactly me. And we view it completely different. We say that the super agent, or your personal agent, it belongs to you. It doesn't belong to anybody else. It's your agent. And you should have the ability to say, I want my agent to learn about X because I'm interested in X. And I should be able to say, well, I want my agent to learn about Y because I'm interested in Y. And the two agents, even though they're independent of each other, they should be able to evolve differently. You can only do that if you own your own agent, if you have the right to derive how that agent is going to evolve.
Is this where the
Charlie,
identity keys come in?
Yes, because the only way, so I can have my own agent, and I can tell my agent to use available resources like the web, and my agent could never talk to another agent if that's what I wanted. It's my agent. But if my agent meets your agent, they need to be able to exchange an identity key so that they can identify each other and know how to talk to each other securely. And you think about it, Mark, when you look at identity, there's this idea of how do I identify? That's my own personal view thing. But then I have identifiers that are applied to me. And identifiers are applied to me by people in society so that they could identify me as one of any number of other people in that society. Your first identity is a gender, your first assigned identifier is a gender neutral entity. It's called baby. You're simply the baby. And then when you're born, you're typically assigned a gender identity. And then you're assigned a hospital bracelet identity. And your parents would assign a name to you. And then your name gets registered in the US, gets registered in the county, and they assign a birth certificate identifier to you. And so you get all these identifiers that are thrown at you. So you can't escape this idea of issuer, holder, and verifier. Somebody issues an identity, you hold it, and then they have to be able to prove that it really is you. That doesn't go away. I don't see that going away, even in a hyper-connected universe.
Charlie, we are getting some amazing chat interaction here. I thought I'd pull up some questions. Heather asks, how would we interact with our agent? What does the interface look like?
So Heather, it's an awesome question, and we explored this. That, is it a text-based interface? And the answer is no. Would we be able to talk to our agent? Well, yeah, we should be able to talk to our agent, because what language you use, what words you use, all of that has to be ripped apart and parsed by the agent so that the agent can interpret it. But as long as the agent can form that idea of what is it that Heather is asking me to do, as long as it can form the idea, that's what matters. Because it has to say, let me listen, or let me read, let me get some input. If I can understand what Heather is saying, then I can contemplate, well, what does that mean based on everything I know? And if I can contemplate what it means, then I can figure out what am I actually going to do in response to that. So Heather, think of it like when I use this example a lot. You teach your kids, hey, we finished up dinner, grab the dishes, take them, put the scraps in the garbage, and put the dishes in the sink. And so we give the kids a directive that we want them to do. And then our kids typically would think about it. They'd contemplate it. Do I want to do that? Can I ask my brother or sister to do it? Can I ignore it? Maybe pretend like I didn't hear? Or should I actually do the work? And so your agent has to be able to do that same thing. It has to be able to contemplate, what is it that's being asked of me based on everything I know, and then go through a sequence of steps about whether or not it should actually do something, figure out what it's going to do, and then do it.
Yeah, and the input capture technologies are getting better and better, whether it's text or whether it's voice or whatever it is. Maybe we get into an fMRI kind of Neuralink kind of communication thing too. I mean, I
can see that happening. Yeah.
Yeah. Heather, great question. We have another awesome one here as well by Vridi. She talks about the self-governance, human self-governance. What are your thoughts on this and the risk of it with this model?
The model is a fascinating model in the sense that I can control my own agent. The question is, when my agent has to collaborate with other agents, what happens and how does that work? And so what you realize is that my agent has a graph, your agent has a graph, and what we're trying to do is we're trying to exchange things between the graph, what we call things of value. And the bigger issue really comes down to is who should control that exchange of things of value. When you look at it in today's Web3 environment, it typically is controlled on a blockchain with smart contracts and some form of consensus. But in a world where you have both decentralized things and centralized things, who should control that exchange of things of value between the agents? And to me, that becomes that's the most troubling part to think about, because it isn't clear that you would want one company, one country, or one government being able to necessarily have total control over that.
Yeah. Well, going back to what you said a few minutes ago, is like, how do you make it that they don't, and that the agents are owned by the individual? Could the agent know the individual so well, or does the agent know the individual well, that the agents can, between them in that negotiation, work out without a third party, without speaking back to their owners, what the best course of action for that value asset is between themselves?
Yeah, technically, so there are rules that you have to go by, right? So compliance audits are a thing. You're not going to escape them. Governments and regulations are things. You're not escaping them. That isn't the intent. The intent is to be able to create models about all of these things and teach them to the agents, so that the agents can participate and do things the right way. So you can't, it's like when we look back and you say, oh, everything in the web, everything in Web3 blockchain, it's so decentralized, you're completely anonymous. And the answer is no, you're not, right? You still have a connection point. You still have an IP address. You still have a blockchain address. And so this is how chain analysis works, to figure out, who's connecting and who's interacting with each other. So it isn't, to me, it's not about being able to be so free-spirited that there's no rules and regulations. It's really about saying that the complexities of the digital world are it's just so complex that people can't manage it. And this is why you really need an agent to represent you in the digital world, to deal with all the keys, to deal with all the encryption and decryption. All of that stuff just goes to the agent and let them handle it.
Do you remember a few weeks ago, Jeremy, we spoke to Nolan and Ben and Coachella about trust? It comes back to trust, and how much should we trust, in this case, the agents?
Right.
Yeah. Another thing, and that's where my head's going. We're seeing a lot of also some great comments in the chat related to this, right? So humans in general have a propensity for good and a propensity for bad, right? And that's a whole nother can of worms that we can discuss. But so if I'm training my agent and I'm pointing my agent to continue to build this mesh of things and interconnect that mesh of things with Mark's mesh of things, but say I'm not kind of the most up and up dude, and Mark's a very stand up, guy trying to do the right thing. How do we look at, like, wait a minute, we may not want Jeremy building his own agent? Like,
well, it's you think of it as, or the way I think of it is that, anything can be used for good and anything can be used for bad. So we can apply whatever rules we want over top, right? But generally, every time that we've tried to add rules onto this thing model, at its core, what we realize is that ultimately there's a thing. It's called a workaround, and somebody will figure it out and add it to the model. So adding these rules prematurely becomes more difficult. What becomes better to deal with is to say, how do I identify an agent? Because an agent is just a process running in a machine. It's property, and somebody has liability for it. So there's issuer, holder, and verifier. How do you hold somebody accountable for something that is going bad?
yeah. So here's a great example. And there's an awesome question in the chat I want to get to right after this from Thomas. But Charlie, so let's say I'm doing something, nefarious with my agent that is causing massive ripples, not with a W, with an R, across the hyper-connected universe. And I asked this question because a lot of our balance, Mark and I talk about this balance between hierarchical systems and emergent systems, and what rules the roost. But in that, how would you answer that in line of that hierarchy
So I think of the world as if the agent is representing me, I'm a citizen of New Hampshire and a citizen of the United States, and so I have rules that I have to abide by, right? And that's not going to change. So there still is accountability in that you can't, if you misbehave or do things that are wrong, you would still ultimately be held accountable.
Yeah. And those wrong things are almost more trackable in this hyper-connected universe than if you did something outside of it.
I think so. It's kind of, I read a book by Katrina Pister called the Code of Capital, and a fascinating book about how law actually still applies and how lawyers help to say what are the laws and how far can we go beyond them, to push those boundaries. But ultimately, it still goes back to everything is based on the property law. And so when you think of it from that context, this machine, this agent that you have, it is your property. And so you have liability. I mean, there's 1,000 questions that still emerge, like, well, who actually taught it to do that? Did you teach it or did it read a book? How did you have enough control over that machine in the first place? And these are all questions they're all things that'll have to be figured out as you go along. But ultimately, if you were to wrap this up, I would say that the world is headed towards this idea of a hyper-connected universe. We see it with the web, we see it with mobile apps and cell phones, and how their cell phone providers are kind of trying to keep you into their particular digital realm, but people still want to move across digital realms. In the US, you're not seeing the super app formation that people expected to see. There's a Wall Street Journal article today. Saw Dr. Funk had posted a story about this Wall Street Journal article on the super app. How come it's not taking off? And to me, part of it is exactly the problem. I don't want another app that's controlled by another company. I want an app that I can control. Yeah. I've got 50 different apps on my smartphone. Why in God's name can I just bring them all together and just move stuff between them? That's what I want to make it so that I can configure. I can say, I want to connect this piece with this piece. I want to move data from here to there. So it's essentially me saying, I want an agent to deal with this stuff so I don't have to.
KYC, that'd be a KYA, know your agent, know your avatar. Jeremy, to your observation just a minute ago, I wonder increasingly what isn't in the hyper-connected universe. So, I mean, how do you get away from it? From the way that we've been talking, you have to go into nature, otherwise you're in it. There doesn't seem much on the outside. It's like what's on the edge of the universe, what's outside of the hyper-connected universe.
Well, because of the way the model is set up, the fun part is that anything in the digital world is already contemplated for, because it's just a thing.
Yes.
And in terms of people, anything that you can think of is a thing, even a concept. It's a question of how good can we model those things and be able to teach them to the agents. And that's, sometimes the models are going to be perfect, and sometimes they're just going to be just adequate, and other times they're just going to be completely wrong. And so that's what you end up with. You end up with just like a person. A person is not perfect.
I wanted, Charlie, my mind's blown, and I'm so energized by this concept and this idea. And I want to be clear to the listeners too. I've read a lot about it, and this is beyond theoretical. Like, Charlie, you've got some patents and some things in place that you're turning this theoretical into actual. Can you share any of those things as kind of a wrap to the discussion? And
sure, I started this project, like I said, many years ago. We filed our first patents, I think it was 2016. So we have a pretty early priority date on these, which is important for us to be able to continue to develop it and explore where it goes. There's about 700,000 lines of code involved in it so far. The next step was that I can build this graph, right? And I can put things in the graph and I can argue about what these things are. There's this thing such that there's that thing. I can talk about that and I can explain it without identifying what these are. But in order for these two things to become linked together cryptographically, it requires an underlying infrastructure of keys that are cryptographically linked. So you have words, human words, and then you have keys. And the easiest way to think of this, Jeremy, is in the web, we have domain names, right? They're words. And the domain names are translated to DNS IP addresses, right? So we translate from one, which is the human-friendly side, to the key side, how things are, where to find things. And so we built a key structure that we call the multi-key infrastructure, and it's just keys, but they use the words that people use in order to figure out what are the right keys to find the pathway to interconnect everything. So we have this running now in the test net that we manage internally. And the next step is we're launching the multi-key infrastructure into low Earth orbit in October. So next month, the SpaceNet version goes up for us to say that we can now have a test net of keys that are being managed on a satellite. And when you bridge these two sets of multi-key infrastructures together, it creates a universal economy, or the economy, the hyper-connected economy. And so that's what we're after, is how do you build this out and test this all out? And then once we get through that, we have to look at how do we launch a constellation so that we can have redundancy and access 24/7 to the satellites in order to have the multi-key infrastructure in both places working together. Now, real world case, what do you do with it, right? So in a simple case, we were trying to come up with simple examples. So we have a software agent that is managing a digital warehouse. And what we do is we say to our agent, tell the warehouse manager you're going to check something into the warehouse. And so it moves a digital asset from that the local agent has over to the warehouse, gets stored at the warehouse, it's encrypted, and you get back a warehouse receipt. Now, why this is important is it proves out the model that we can do this. Now, once I have the receipt as an agent, I can then give that receipt to another agent. I could sell it, I could exchange it, I could use it to take out a loan. There's 1,000 things that I could do with that receipt, or I could take it back to the warehouse manager and say, hey, here's my receipt, give me back my digital asset. And so this becomes kind of fun and fascinating because technically the local agent can say to the warehouse manager, create a custodial agent over here, and I wanted to manage a Bitcoin. So tell me what address I should send the Bitcoin to. So the local agent knows the address, and it sends a Bitcoin over to the custodial agent over here. All right. This occurs on the blockchain. You can see that it went to that very specific address that the custodial agent is managing. But the custodial agent is the one with the private key. Nobody else has it, just the custodial agent. What makes it more interesting is that I can now say to somebody, hey, I'm going to give you the key, Mark, to the custodial agent. And so now I'm transferring ownership of the custodial agent to you. And now you have access to the custodial agent, which has the digital asset, or in this case,
not of the thing. Yeah, the ownership of the thing, not of the thing, but of the agent representing the thing.
Exactly.
To direct the thing. Yeah. Wow. Yeah. Super cool.
So it's a way of being able to say that you can transfer a digital asset on chain, and then you can take the custodial agent, the ownership of the custodial agent, and we can transfer that off chain as we need to for various reasons. And then you do that up on the satellites. So this way, then people would be more trusting of the agents running on the satellite because they're harder to hack into. You could shoot it down, but if you have multiple satellites up there, then you have the redundancy you need.
There's so many different pieces and parts that go into this big vision that you are actually making tangible strides to pull off. It's amazing and wonderful, because a lot of big ideas too, like going back to my book, the guy that wrote about the fact that we could be living in space in 1976 and had the technology to do it, but we didn't, because it was too big to undertake, right? It's too big of an effort, right? This is a really big effort, Charlie, and I commend your ability to kind of pull these things down into building tangible things to get there. And I think we have to have another follow-up on this, Mark, because like, I want to stay in touch with how this stuff is happening, what's going on. This is a good precursor of what the hyper-connected universe could be. But where can people find out more about this, Charlie, and more about you and all of that?
People can absolutely connect with me on LinkedIn. You can follow along. I generally post about, I mean, Mark, I have to admit, many times I was posting about Web3 and I kept trying to say, there is no Web3, there is no Web3. You have the definition wrong. It keeps changing, but, and eventually I realized that I was wrong, because there is something called Web3. It's just that Web3 is a thing, and it's inside the hyper-connected universe. And so you want Web3, you want cryptocurrencies, you want these blockchain solutions. And there's some amazing work that's being done out there. I love following Keir Finlow-Bates. His work is just, it's just fascinates me. He's a mathematician. If you don't know him, follow him on LinkedIn. Another person I'd love to follow is Samson Williams, because he talks about this, the space economy. And this is where we realize, Samson once said, there's no drive-up ATM in space. And I thought, wow, he's right. So what we need is, we need a digital warehouse on a satellite. And that's where we got the idea from, just from talking with him. So I love talking to people, because I get new ideas, and I'd love to be free and share what we've learned so far with other people and see what they think.
Amazing. I think too, Mark, my brain goes to like, there are a bunch of Thinking on Paper guest alumni that we should pair with Charlie for future episodes to have some fun roundtables. But we are unfortunately over and out of time. Charlie, I think we're going to try and do this again. Very fascinating. We'll post a follow-up. Mark does some great post-show write-ups. A little bit more of a thanks to Ripple with a W, Dixie in the chat. If you have any questions about Ripple, these are your real life marketing agents, if you will, right? So if you need marketing expertise to augment your team, they're the folks to check it out. Great platform, www.ripple.com with a W. Mark, any closing thoughts on your end?
Yeah, I'm just going through the chat, and there's some really, really interesting observations. One that I see is Vritti, and she wrote about the goals of these models and systems should be to improve human thinking and development. And it reminded me, last week I was speaking to someone from Harvard about AI and students, and he said something very, very similar along the very same lines. It was like, we've got to be careful of using these tools to increase critical thinking, to make critical thinking better, and not use them as a delegation process for creating thoughtful arguments and thinking about things ourselves. And I think that having someone like Charlie thinking about these solutions, aware of these incredible, powerful obstacles that we need to overcome, is we're going in the right direction, at least.
Yeah, I totally agree. And Charlie, if you have some time after the show to jump into the chat thread, I think there's some questions for you that I think would be fun to get some interaction going. So if you're open to that, I would love it.
Absolutely.
Yep. Amazing. Well, thanks for joining, Charlie. This was a pleasure. I can't wait to do it again. Mark, always great to see you.
Again.
Thanks again to Ripple. Check us out on thinkingonpaper.xyz. All these episodes are on YouTube and Spotify. Thanks for joining, guys. Really great to see you. Appreciate all the interaction. See you soon.
Thank you. Bye.